Okay, dear friends, let us see this glucose, the ring size of the glucose. Glucose can be in the 5-member ring or 6-member ring. So we are taking a glucose molecule. Let us assume that it is in 6-member ring. When it is a 6-member cyclic ring, you will have two forms. One will be alpha, another will be beta. So alpha, beta, both the forms, when we can segregate them into two groups, we are taking only alpha D glucose. When this alpha D glucose is subjected to methanol in presence of hydrochloric acid, this methanol will react with the first carbon's hydrogen, which is in cyclic structure, and it will get methylated. And this is on the right hand side, we will call it as alpha. When we are using mild methylation reagent as methanol in hydrochloric acid, only first carbon is getting methylated. When the first carbon is getting methylated, we will call it as glucoside. And the group is on the right hand side. Anomeric carbons group is on the right hand side. That's why we are calling it as alpha. This D indicates the hydroxyl group, penultimate hydroxyl group. That means last but one hydroxyl group. It is on the right hand side. So when it is on the right hand side, we will call it as D. So this is D alpha D glucoside. And you should observe that there are only minor changes in a specific part. Total rest of the molecule will be same, and wherever there are changes are there, that should be indicated. Now this alpha D glucoside will react with dimethyl sulfate. What is dimethyl sulfate? It is nothing but a sulfuric acid. H2SO4 is sulfuric acid. In sulfuric acid, the two hydrogens, if you replace with methyl, that is CH3 group, CH3 taken twice, SO4 will be called as dimethyl sulfate. Why we are using dimethyl sulfate? This dimethyl sulfate is rich in methyl groups. These methyl groups can be donated to this glucoside, then we can convert into methylation. So where are the possible sites of methylation? Hydroxyl hydrogen is weakly bound, so this methyl group will come and the hydroxyl group in methanol and hydrogen will go out as water, and this methyl group in DMS they will come and sit in the position of oxygen. You can find such hydroxyl groups 1, 2, 3, 4. So you will get a tetramethyl compound, methoxy compound. This methyl group is different, it is coming from methanol. You try to remember that. So this methyl group, this is also a methyl group, no doubt. The only difference is this methyl group, it is easily undergoes hydroxylation or hydrolysis, but these groups they will not undergo. Here you are using a mild methylating agent and only first carbon is methylated. In second case, what happening, when you are using dimethyl sulfide, all hydroxyl they are replaced with methyl group. So you are getting a tetra-O-methyl compound. The name, if you see the name methyl, this methyl is separately said as this is a glucoside. Methyl, tetra-O-methyl. This oxygen O-methyl means methyl group is present on the oxygen. So such methyl groups 1, 2, 3, 4. You are having 4 methyl groups. So we will call it as tetra-O-methyl. Methyl, tetra-O-methyl. Alpha means this is on the right hand side. D means this hydroxyl group is on the right hand side. It is a glucoside. So naming is like this. Why we are methylating this compound? When you do methylation, further when you do oxidation, these groups may get oxidized when you use a strong oxidizing agent. So if these groups, if you don't want to get oxidized, what we are supposed to do? We should cap it. We are fixing it. We are locking it using methyl groups. When you methylate it, these all groups will be methylated and only first carbon, the link carbons, they are free. On further, if you use hydrochloric acid hydrolysis, hydrochloric acid will only remove the first carbons, the anomeric methyl group, and you will get a aldehyde and you will get an open chain structure. This cyclic structure is converted into open chain structure in presence of methanol. Now you can see first carbon is linked to fifth carbon. That's why when you hydrolyze, you will get this first carbon free and this fifth carbon is also free with hydroxyl group. Now we will see whether the link is first or fifth by using another further oxidation. When this compound oxidizes, this first carbon as it is freeze, this aldehyde that will be converted into COO, that is carboxylic acid. And the fifth carbon is having hydroxyl. As I said now, when it goes oxidation, this alcohol will be converted into keto group. So newly this molecule is having a carboxylic group and a keto group. So we are calling it a keto acid. So this will be converted into keto acid. On further oxidation, what happens? These bonds between these groups will break. They will get fragmented towards this keto group. There is a chance of fragmentation here. That means 1, 2, 3, 4, 5. So fifth carbon, fourth carbon breakage may take place, or fifth carbon and sixth carbon breakage may take place. Let us imagine if the breakage between fifth carbon and sixth carbon, here if it breaks, this C double bond O will become COOH. That means on the top you are having a COOH, on the bottom also you are having a COOH. You will have two COOH group, and 1, 2, 3, 4, 5 carbons with two COOH group. We will call it as glutaric acid. In glutaric acid, these three oxygen molecules, they are methylated. So we will call it as 2, 3, 4 trimethoxy. 2, 3, 4 trimethoxy. This is nothing but a glutaric acid. This 5 carbon molecule will come only when there is a double bond at fifth carbon. That clearly indicates that first carbon is linked to fifth carbon's hydroxyl, not on the fourth carbon. Or we can say that it is glucose is in pyranose structure, not in pyranose. And as I said now, there is a chance of getting broke here. So between fourth carbon and fifth carbon, if the breakage takes place, this lower fragment, this oxygen, it will come as methoxy state with the two carbons, and this upper part, this carbon will be converted into COOH, and you can see COOH here, and CH3H, CH3H, CH3, COO. We are getting a succinic acid. 4 carbons are there with 2 dicarboxylic acid, which is a succinic acid, with 2, 3 dimethoxy succinic acid. These three fragments clearly say that when there is a break between fourth and fifth and sixth, then only you will get these products. And this C double bond O will form only when there is a link between first carbon and fifth carbon. This clearly indicates that glucose is having a pyranose structure but not a pyranose structure.